if you have any questions, or if you have collected questions from your local farmers, please don't hesitate to raise your question at this platform. Professor is going to give you a professional discussion, and very possibly you're going to get the solutions from this platform. I hope that today we have more distributors from South Africa and other African countries. I know that you are already on a holiday, the season spirit. So when we are approaching the Christmas season, but thank you very much for being with us. Thank you very much once again for tuning in.
Hello, and actually we are in here in my office is kind of study in the holiday season. Not too many people show up. One big thing is that we have use or lose your annual leaves. So everyone earned vacation time, and you have to use it by December 31st. If you don't use it, you lose it. So started January 1st, we started a new year and started counting again. So many people just take off. I saved some time for days for later use for snow days. In case of snow, cannot drive and we not show up. So, and we started have a holiday party in the office. And so this is a lot of people. I received some Christmas gift already. So if somebody express send me a big package of the chocolate or something. So happy holiday. And I got some message. Somebody say about use. Somebody say ask some, if I use the NOPF, do I need to use conventional fertilizer anymore, or we need to combine them together, or how do we use it? And some people said, okay, the NOPF is so powerful. When you have NOPF, you don't have to use conventional fertilizer or chemical fertilizer anymore. This is we discussed this a lot in the past. This actually depends on how do you, every situation is different. First thing that we need to analyze your soil. A lot of time when we have let me see, how do I start here? So we discussed this in the past many times. The thing is, a lot of time we need to understand your soil. We find out all the NPK or general fertilizer you put in the soil only can be used for 30%. You lost like a 70%. So it is the plants, they need a lot of nutrients. Well, fertilizer, we say fertilizer are food for crops. Like we people, before I start class, I have to eat something. If I don't eat it, my time is 9-10 a.m. in the morning. So it's past my breakfast time. I have to eat. If I don't eat, I get a low blood sugar. A lot of people have the high blood sugar issue. I have the other way. I can get a low blood sugar. Actually, I passed away a couple of times when I low blood sugar. One time I was like 15. That time we were so poor, we didn't have food to eat. And it's cold, it was winter time. And I was given a ride to a guy to attend a funeral. It's a long riding I made like 5 cents for the whole trip. And they gave me 5 cents for the riding fee. And I get it when I arrived, I passed it away. I totally starving and then no blood, no sugar in the blood. So didn't know what happens. And so finally eat something and recovered. Second time I was in the college. I was like 18 years old in the microbiology lab. One of my classmates, two of us find fungal spores under the microscope. And he claimed that he found it, and I didn't find it. I was frustrated. And I kind of passed it away. And in the lab, so it's all the professors around. So I remember that Professor Wei, she knows. She said, okay, it's a low blood sugar issue. So she gave me some glucose sugar water and immediately recovered. So I know what's the trick. Is actually I have a low blood sugar issue. So the human, we need the nutrients in the blood all the time. That's why my family, only me and my mom have this issue. If we cannot stop, if we stop, we pass out. My father never stopped. He never feel like hungry. The plants, they need nutrients all the time. They need a large quantity, a lot of stuff. Actually, most nutrients they need in the soil for the whole agriculture system is a carbon. You don't realize we never feed them. We don't in the fertilizer. We don't have carbon in the fertilizer. Actually, they need. So we need to put a lot of carbon in the soil. And this carbon, and you think about the plants, the green plants, they do photosynthesis. The photosynthesis, I don't have a formula here. Actually, they use carbon and the sunlight. So they make the carbohydrates, the sugars. So carbon is mostly important for the plant's nutrients. So CO2 under the sun and with ATP, you create ATP, and with all this chlorophyll, the leaf, the green stuff, and I have plants here. This is green leaf. This is green leaf under the sun. That's why you need to put the plants under the sun, even the flowers. If we don't have a sun, you cannot do the photosynthesis. Photosynthesis, the material is carbon. So carbon is the most important. A lot of people just ignore that or even didn't know that. So most important that we need to check your soil. You have enough carbon in it, enough C in it. If not, what's the problem? Carbohydrates, these fibers, plants residues are mostly carbons. Some proteins, when they dry, you see mostly the carbohydrates. When you burn, these are all the Cs. So in the soil, if we don't have that, what that means is your soil, you don't have carbon for microorganisms or earthworms or the little animals. They don't have anything to eat. So we need to do the feed the soil with C, let them have enough food. And actually is you adding organic material into the soil. Two functions. One is you're feeding the microorganisms or earthworms. They basically they eat the soil. They eat the soil and microorganisms and organic materials in the soil, and then they pass out their purpose become very nutrients for the plants. So we feed these animals, and their purpose, or they die, their bodies now they become organic nutrients for the plants. This is one function. We feed the ecosystem of the soil. Second, when we feed the soil, is actually some water-soluble stuff will be available for plants to use. So we have to feed the soil. We need to know if your soil have enough organic material in it. If we have a lot, and the things we try to make your soil nutrients in the soil available. The easiest way to make your nutrients available in the soil is water. You give them some water. When you water the plants come back and it will be very good. The water have two functions too, like other food. The water, first thing is we give the water supply for the plants immediately. How do we know? The plants, they have stem, they have vessels inside, in middle of the stem. If you cut it out, they have some horizontal. Sometimes you can see the holes, sometimes you don't see vessels. All this stuff, they pass the water or inorganic nutrients from the soil up to the leaves. And another kind of vessels, they pass the photosynthesis material from the leaf, pass along to the whole plants. So I have two systems. One is the water and the water-soluble nutrients go up. Another is organic chemistry, organic material, all the photosynthesis material from top going down everywhere. So plants have two different vessels to transport all the nutrients. So when you water them, first thing they give them water. If the plants, if cells is dry, and the cells they will wilt, and you see the leaves will be soft, there's just not enough water to support it. Another thing is you give them water, you make a lot of nutrients in the soil become water soluble. So plants can get the nutrients. Even you have enough nutrients in the soil, if you don't have water, you cannot use it. So that's why water is another most important nutrients. So the carbon is important. Water is important. These two, normally we don't think as the fertilizer. We don't think as the nutrients for plants, but they are the most important plant nutrients. So always think that too. That's two things first. If we have this, how do we supply water? It's easy. Everybody knows. You just give them water, either by watering or you are dripping. If you have enough money. My garden, I don't have it. The dripping is kind of like you have to make a system, but you can water them. My hometown, we go do this is if this is a flat soil, and if the plants here, and if we put it in the like 6 inches away, or like 80 inches away, we make a ditch, and the water you can from the one end of the land, and you pass all the way along it like a small canal. When we planted, actually, when we have the cultivator, we planted the eggplant. Is that one? Or talos. Eggplant talos, we make a huge raised beds, and plant the eggplant on the raised one. And in the middle, actually, is a canal. So almost every day, we fill the canal with the water. So the plants, even you don't give any fertilizer, you just give the water. The plants may doing well because you give them water to drink, give them water to help the nutrients in the soil, make them available. A lot of soil in Africa, in a warm area, because you used to have a lot of plantation or plants or trees cover, except some desert area is different. You don't have any plants, then your soil is very poor, have nothing in it. But you still have some minerals maybe in the soil. So if you give them water, they do some good. For the traditionally, we have 1,000 years agriculture, we didn't have a lot of fertilizer. That's why the yield was not that great. Only give you water or give you some animal manure. Like actually, we don't use that anymore. But my hometown, we still use pig manure, human manure. The soil system, every family have their own sewer system. They will storage all this and they get a fermentation. Then after fermentation, we can use in the soil. The thing is, all the animal manure or human manure, you have issue of the bacteria or diseases. So you have to make sure totally fermented after long time, and these parasites, diseases, bacteria, they all died during the fermentation. For the average people, just open, if you can cover. And for the rich people, in the 70s, we had actually have some, one of the movement is every family build, make all these manure containers, all covered, sealed, and they give a pipe. So all the air, all the gas phase actually become a fuel of the house. You can light, you can cook. So that same time, because you're sealed, you can get a totally fermented, kind of composted manure. So it becomes all liquid. So the liquid part is very healthy, safe, and the gas part transported to the kitchen to do the cooking. For the average farmers, like right now, I'm doing in my garden is I save all the veggie or anything kitchen stuff, put a compost, a bigger pile, make a compost. So these are the traditional, you can make all the compost. Then this way, you can dissolve, digest, or make it your plant material become available for plants to use. So this is things that we need local soil. If your soil is organic material a lot, it's kind of rich, then you don't have to put a lot of conventional or chemical fertilizer into the soil because you have enough nutrients. Now what we needed to do is we only use NOPF at top dressing to boost. NOPF have more than nutritional value. They have the plant stimulus, have improved immune system, have a lot of functions more than nutrients. So if your soil is very rich, you can use only NOPF. If your soil is not rich enough, then you should analyze to know what you have. Do you have enough organic material? Do you have enough NPK in the soil? If not, then you need to add it. So I hope most people see this chart. You see, this is NOPF only. This is control, which means nothing, only water. This is conventional only. This is both. You put a conventional fertilizer as normal use, plus NOPF. This is cut half NOPF, half conventional fertilizer. Oh, this is 75%. So these are all the combinations. All the numbers here, A, B, C, if same letter, which means statistically they are same, even the number is different, but we don't think you are significant change the results. Only the letter is different. We can give you 95% insurance on predicting if you use this method, you will have 95% possibility to get increased synergy efficient. We have this ABC value, normally we have 95%. If you go stronger analysis test, you can get 99% assurance. So basically it's a 1% level or 5% level. So it's called an alpha level of you. If we talk any statistical courses or experiment design courses, they can tell you what's the alpha level. If the alpha level is significant, then you give a different ladder to indicate it. So A, B, so this chart, for this, we can say totally different. But this T2, T4 looks like a different, but actually for the experimental wise, for scientifically wise, we think are same. So you see, combine NOPF and the conventional fertilizer may be more significant, more efficient, have high yield, and also may be more economical wise. So when we think about the fertilizer, we have to think about all these components. For when you look at the soil, you need to, how do this top should decompose animal manure, green manure. Green manure is like a lot of like soybeans, pea, or alfalfa. I don't know if I spell right. So this stuff are considered as green manure. When you green manure, you turn over and put in the soil. They not only give a lot of NPK proteins, they also give a lot of carbon C in it. Animal manure is kind of almost getting almost everything. So if we put all the animal manure in it, we have one of the issues, you can get animal manure concentration issue too. If too high concentration, you will not grade either. So you need to dilute it with the water. Make sure it's diluted water is also based on your water situation. You can one thing is we discussed a lot of seed soaking the seeds issue. The soaking the seeds issue is some people soaking the seeds because the seeds after soaked, they are soft. They have a lot of water inside the embryo. Then when you put it in the soil, make sure your soil is moisture. How do we get it that? It's because how do you make your soil moisture? One of the practices is you open the soil, make it open, make sure it's ready to give the seeds. Then you give it diluted, maybe 5% or 10% of animal manure. Basically, you put 1 part of the animal manure, it was liquid anyway, fermented, add 9%, 9 parts of the water. Then you pour into the place you are going to put the seeds in. This way, you give your soil enough moisture and give you some nutrients. They're serving as a base fertilizer too. So when you don't have the NPK, don't have the chemical fertilizer, you just use this as a base. All this compost, animal manure, or green manure, they always provide a long time usage for the plants because they are kind of like totally organic, maybe still in the solid phase. They are still not a liquid yet. So when you put a compost, because we have like my hometown, we have a goat or sheep manure. This is not stink that much. The pig manure is wet. It's not easy to spread. But the sheep or goat manure is kind of dry. So we just, that time I even didn't have gloves. Gloves is too expensive for us. We just break it up and spreading into the soil. Then we cover, give it a little bit of soil to cover them. We don't want to put this all the animal manure, compost, all this fertilizer in contact with your seeds. So all this add into it. Then the amino acids, the NOPF, the liquid fertilizer, we use as a dressing, the top dressing or side dressing as a boost. We provide the conventional fertilizer or the animal manure stuff. They provide a bulk value, give you a lot in the soil. When you put a lot in the soil, it's not immediate for your use. Only a very small portion plants can use right now. We know because we will be affected by the moisture, if it's raining, or if you give them water immediately. If you didn't give them anything, plants cannot use it. So that's why they bury it in the soil. You can last it for the entire season. For NOPF, unconscious, it's much easier because it's not encouraged. We don't recommend you put NOPF in the soil because you too expensive, the volume, and it's not efficient. But if you really want, if you put a drop system, if you can target, if you pinpoint the plants where you put the NOPF, you can do it. You can make sure you're very close to the roots. You don't lose them. If we're too far away, it may be not efficient. We always think do everything for the farming. The first thing is do I make money? To me, this is now number one important. If I don't make money, I may don't do it. Of course, I do my garden. I don't make any money. Actually, I consider it as exercises. And I have full-time job. I'm not, living on the farming. Even I have farm, I don't do much. I go to my farm less than one time per month. So it's not for money. It's for enjoy. I just go over there. Oh, that's a lot of land, and I plant something. If I don't get it, don't get it. If I get it, get it. So totally different. But if you are actually your work, you live on it, you make money from that, then you need to think efficient, the money cost effective issue. Always think about the money. If too expensive, don't do it. So NOPF, the liquid fertilizer, the most cheap way is spray on the leaf. You make sure you spray on the back of the leaf. You make sure you don't spray during the hot sunlight condition. We want them spray, keep them on the leaf for a while in the liquid film. So this way the nutrients can move to the stomata, some holes of the plants for the leaves. Then they don't dry out immediately. If they're too hot, you spray on the leaf, they dry out immediately and become powder. They're not water soluble anymore. And then the wind blew, you lost. It's one of the reasons why you don't spray during the hot time, dry time. We want to spray early morning, late afternoon. We want the NRPF liquid. The organic film can last a little bit longer on the leaf. Maximize the transportation of the nutrients into the plants. You spray 1 liter into your land, you can get a liter. Don't lose them. That's a very high nutrients, high value stuff. So this is a thing. And all the fertilizer, same as all the chemical or non-chemical pesticides. Most important is how do you scientifically use them. It's not like, oh, do it. I give you, you're sick. I give you some pills. You take it. Or if you feel the plants, you feel like, oh, so yeah, I see something. I'm going to spray insecticides, spray fungicides, or spray herbicides. No, it's a lot of science there. The fertilizer, little bit easy, more simpler than pesticides, but still, you need to use scientifically. Scientifically here for the fertilizer, basically have two things: is time and a space. The time is when to use it. We produce some. Where's my? I don't know where it is, but we produce something pamphlets, the threefold fertilizer guidance for some major crops. We basically provided this for the Africa region. We didn't target for the Asia or Europe region because the growing season is different. The raining season or dry season for your area. For my area, we have spring, summer, fall, winter, 4 seasons. is totally different. So when you're different, and you have different strategy, guidelines for each fertilizer, each crop, how do you cultivate? So the time most important is for the fertilizer, conventional fertilizer, all these above these all fertilizers, we have to use base fertilizer or dressing. This as two different categories. So for the base, is something you're looking for long term. So it's always hard to deal with. It's not easy to apply. So we need to put them into soil before you plant the growing season. That one, they are compost, all the growing manure. But it's not 100% that way. You still can apply all this growing manure, all this animal manure compost in the growing season as side dressing. How do we do it? That's easy. It's still a couple of things that always have issues. For this manure, if you matured, which what I mean matured? Matured is already compost, fermented. You don't see the actual original plant shape. You don't see the leaves, you don't see the branch, you don't see the stems, you don't see the roots. They all become powder or granule, or kind of like very small pieces. And these are called matured compost. This kind of compost is already helped by the microorganisms. They decompose all this material you put in. That's why you don't see the leaves. That's why you don't see the stems. You don't see any plant parts because they are all decomposed. These are safe to use anytime. You can, if you're lazy, you just put it on the top of the soil. The best is you put it on soil, you cover one layer of the soil, and you cover it. This way they don't dry out. They can continue be used by microorganisms. They feed them. By the raining, they can wash some water-soluble nutrients to the roots, and the roots can use it. If you put uncomposted, not a compost, not a mature plant material, if you put too much, you have an issue for the competition of the nitrogen. That's why if we do compost, if we do a compost scientifically, you need to add nitrogen chemical fertilizer into your compost pile. Why? Because you give them all the compost, all the kind of the seed, mostly carbohydrates. And these microorganisms, they want to decompose. They want to eat this plant material. But the microorganisms, they need a protein too. So if you don't have enough protein, which means they need a lot of nitrogen. If we don't have nitrogen, they actually take all the nitrogen away from your compost. So then they compete nitrogen with you, which means your plant. So microorganisms can compete nitrogen with the plants during the fermentation time, especially in early time. And actually, you give a lot more organic material to the plants. In the end, you actually remove nitrogen from the plants. Plants can become weaker than before. So you think, why? I give them a lot of food, you're even getting worse. Yes, because you didn't think about all the fermentation procedure. The microorganisms in the early part, the whole compost, you don't have a lot of protein. You don't have nitrogen in it. You only have mostly carbohydrates. So plants, you are not stronger. You are not tougher than the bacteria or fungi. So they are stronger. They take all the nitrogen away. That's why your plants getting even unmatured, not fermented organic material if you can. But most of the time we don't think that way. We just ignore. We say conventional compost or scientifically compost. Scientifically compost, you need to monitor the nutrient profile. When to add some, like a urea, the nitrogen, into the soil, into the compost. Or in the later time, you don't have it, because later time you will have enough nitrogen in the anyway. So this is the time issue. For space, we say same thing. So it's time and space for all this fertilizer. How do you use it? The space, which means our fertilizer, NOPF, is best applied on the leaf. Okay, this is what we look at this. Now have some details why we the explanation. You don't have to read it. I already talk a lot about all these details, but you can split for all different organic fertilizer versus chemical fertilizer. Why all this? And as a student, it's anything. If you do something, or if you training your kids, the most thing you should tell them is ask why. Not tell them what do you need to do, what do you have to do. No, don't ask them that. Ask them why do this, when do you want to do it. You make these questions. Don't give them answers. Don't give them resolutions. Just make them think. When you think, when the kids understanding the question of the homework, then they will find the way how to do the homework. Don't tell them the results. Don't tell them that 3 plus 5 equal to 8. Don't tell them. Just ask them, how do you do this? Why? Keep them asking me why. So same thing here. Here, we keep ask everything why. So the following all these slides is all the whys. You can culture is funny. You can just use common sense. You can get most of them. But if you want to do the best, common sense is not enough. You have to do a lot of reading, calculation, analysis. That's why the yield improved a lot of times since in the last 70 years, last 100 years, maybe only last 80 years. The whole fertilizer, whole pesticides, in the last 70 years, they changed so much. fertilizer is changed from conventional just the NPK. In many countries, they overuse, like China. When I was a kid, we didn't have much. After that, they just abuse NPK. You have too much use because it's easy, because it looks like cheaper. You damage the soil. You got a lot of issue. They have see something here. Low efficiency, a lot of environmental issues. You can think about a lot of issues. For last 10 years, a lot of new fertilizers come out. They are like an OPF. The liquid more efficient and actually more than fertilizer only. They acting as a lot like Chinese medicine. You not only treat the plants, give the nutrients food, they also improve the plants' stronger immune system. A lot of biological, natural process. So this is for fertilizer, and also the usage method, application method changed a lot. For the pesticides, for the insecticides, fungicides, herbicides it's also changed a lot, but not as much as the pesticides, insecticides, or all got confused. Pesticides, including insecticides, fungicides, antibiotics, and herbicides. So each deal with different category. For insecticides, kill insects, and for the miticides, kill mice. Insects are different from mice. It looks like, oh, a lot of people think mice are insects. No, mice are not insects. Spiders are not insects. They look like similar, totally different. What's the difference for the insects and the mice, insects and the spiders? Insects have 6 legs. They have 3 pairs of legs. 3 legs on one side, 3 legs on the other side. The mice, spiders, they have 4 legs each side. So they have 8 legs. The body is also different. Insects, they have a head, have thorax, have abdomen. They have 3 segments. But of course, have some different. Some insects, they fuse together. Looks like 2 segments, or looks like sometimes 1 big segment. But evolutionarily, insects have 3 legs, 3 body parts. So insects have 3 body segments, 6 legs, 3 legs each side, 2 wings each side, 4 wings total. The spiders, the mice, they don't have wings. They have 2 segments body, or 1 segment. And they have, most importantly, different is they have 8 legs. There are 4 legs each side. So if they are totally different, then when you use the pesticides to control the insects, control the mice, so you have to be different because the mode of action is different. Talk about the mode of action. In the early part, almost all the insecticides are nerve insecticides. They work on the nerve. A lot of nerve chemicals between one nerve, another nerve, they place contact. They have chemicals in the middle to transmit to information from nerve A to nerve B. they are very similar to the human. That's why when you accidentally drink any old nerve mode of action insecticides, people get killed because we share same mode of action of the nervous system. Human and insects are very similar, almost the same. So pass one nerve here, we want to pass the signal to the next nerve in the middle. They have chemicals to bond each other. With the pesticides, when you give the pesticides, insecticides to the insects, they occupy some place locations. So insects, when you receive a small signal, and they will have jump so much respond from the next signal nerve, and because so much too much, and they kill. The human same thing. When you see some people toxic by the insecticides, which means your nerve. You have a very small nerve signal. When you get insecticides inside, you amplify so many times and you got to kill. So this early mode of action insecticides is very toxic. Some people, one drop can kill one person. I saw it when I was 15, 14. I saw several people died from insecticides. And it's only a little because his finger was cutting, so it's open. So insecticides, he didn't use gloves. At that time, we didn't have gloves. And so get in and they died. After that, we try to minimize these nerve system insecticides. Now we changed a lot. The most newer insecticides, we work on the skeleton because try to avoid the similarity of the human and the insects. We share the same nervous system with insects, but we don't share the bone system with insects. Where are bones? Our bones is inside the meat. Bones is inside. Where is the bone of the insects? Insect bones are the outside. Their skin are the bones. They don't have internal bones. So they have totally different bone structure compared to humans. So if we drink this kind of insecticides, and we don't have an issue because we are not have skeleton, we don't have external bones. We don't shade skins. So that's why now most of the insecticides are safe because we totally understand the human and insects, what is anatomy, what is the biochemistry, what's the difference. We try to avoid anything we share. We only use the targeted points on the insect has. We don't have it. So this is much safe. Well, we talk a lot of other agriculture, but under fungicides, herbicides, same a lot of issues. We try to more selective, not general. We try to not use any general pesticides. We try to use target specific. That way be safe. But mostly we concern is honeybees, fish. We don't want to spray anything to kill the honeybees. We don't want to spray anything to kill the fish. We don't want to spray kill the animals in the like frogs or something in the field. So if we can try more, understand more the agriculture, more the biological, of all the plants and animals. This is the most thing we always ask with the why. Keep asking why. When you answer all the whys, and you will be able to see where is the trick, where is the place I can do it. This is scientifically used fertilizer, scientifically used all the chemicals, including pesticides. This is their foundation. How do you pick? How do you use? What time you use? While we continue talking all day, we save some for next slide. If you have questions, let me see if I need chat. I can't find it. Okay, find it. I cannot see the message here, so I hope it's another questions. Hello. So we can see. I'm not sure. I think we have a schedule for next Saturday for the 2 lectures. So Miss Zhang and Miss Ming, they continue present all the basic fertilizer trainings. And 王倩在吗？
Yes, here I am. I saw one question. I'm going to forward it to you. And next Saturday is going to be one of the basic presentations of NOPF, but I do believe after 7 days it's going to be 20th. So if you are still there, if you haven't gone back to your village, so please join next Saturday's basic NOPF presentation. Still, if you have any questions, kindly forward. I see Mr. Budiman is with us. You can forward to Mr. Budiman, to your general manager. Thank you for being with us. Thank you for tuning in. So I'm going to forward these questions to you, Professor.
Okay.
So we can unmute yourself and say thank you and good night, good day to Professor. We wish you all, happy holiday seasons.
Happy holiday.
Happy holiday to each and every one of you.
Bye-bye from Zambia.
Thank you.
Bye-bye.
Bye.
Happy
Bye.
holiday, Professor, Madam Rainey.
Thank you, Mr. Budiman.
Mr.
Thank you.
Budiman, enjoy your festive season.
Same to you.
Madam Rainey from Ghana.
Thank you.
Thank you, Professor, for the presentation. Madam Reni, thank you.
Thank you.
Thank
Okay.
you, Mr. Time. Thank you.
Bye.
Thank you from
Thank
Kenya. Happy
you.
holiday.
Thank you. Bye.
Bye-bye.